Hello and welcome to Pre-AP Chemistry. If you clicked on this video, you must be wanting to learn about chemical nomenclature. So let's not waste any time and jump right in. The word nomenclature itself means the rules and process by which names are assigned to a chemical. The name will tell you a great deal about the properties of that chemical, and getting it right could be the difference between getting a question right or wrong. So stay focused and take notes. And if you're one of my students watching this video, remember that I will grade those notes in class. To begin, it is important to remember that there are two major types of chemical compounds, ionic and covalent. Covalent compounds are also sometimes referred to as molecular compounds. We have learned about the differences between these two compounds in detail, and so I will only review the differences that are relevant to this lesson. When you look at a formula whose name you must determine, the first question you ask yourself is, when am I ever going to need this in my adult life? I'm of course joking. You ask yourself if the formula given to you is that of an ionic or a covalent compound, because once you answer this question correctly, the rules you will follow for determining the name will differ greatly. So let's look at the two formulas that are on the screen. The first one starts with the metal. This tells you that this must be an ionic compound. The second one starts with a nonmetal. This tells you that this must be a covalent compound. And so the requirement for an ionic compound is that it must start with a metal. The requirement for a covalent compound is that it must start with a nonmetal. Now that you know how to determine the type of compound, let us see the rules that are used for each of those. For the sake of brevity, I am going to cover only the ionic names in this video and the covalent compounds in a separate video. All ionic compounds can be grouped in two main types, binary and tertiary. As the name suggests, binary means only two elements make up the compound, a metal and a nonmetal. However, in a tertiary compound, there is a metal atom, which is the cation, bonded to a group of atoms that together make up the anion. You will find a list of these ions at the back of your periodic table under the name of polyatomic ions. We call them polyatomic because they have multiple atoms that are bonded together, but act as if they are one big anion. Be sure that you memorize the names of these major polyatomic ions. It will save you a great deal of confusion. Now that we have learned about the different ways to classify the ionic compounds, let us review the rules for binary ionic compounds. Remember that a binary ionic compound is a type of metal and a type of nonmetal. So for example, NaCl would be categorized as a binary ionic compound because there is only one type of metal and one type of nonmetal. Similarly, BeCl2 would still be a binary ionic compound because I want you to remember this. There is only one type of metal and there is only one type of nonmetal, even though you have multiple atoms of the nonmetal. Okay, so binary means two different types. So let us talk about the process by which we will assign name to this chemical whose formula is BeCl2. The first thing you do is you write down the name of the metal by finding it in the periodic table. In this case, your metal is Be, which is called beryllium. Next, you will find the name of the nonmetal from the periodic table. In this case, your nonmetal is chlorine. But you're going to make a small change here. Instead of calling it chlorine, you are going to change the name of chlorine to chloride. And so we can summarize this process of naming binary ionic compounds in two simple steps. In step 1, you will write down the name of the metal without changing it from the periodic table. It could be sodium, potassium, iron, cobalt, nickel, whatever it might be. Step 2, you will find the name of the nonmetal from the formula and then change its name. And you have to make sure that you end the name of this chemical with the suffix "ide", okay? And that is very important. So, for example, bromine will change to bromide, nitrogen will change to nitride, sulfur will change to sulfide. I realize that some of these names might sound a little weird to say out loud, but as long as you follow the convention of ending the name with "ide", you will get the right answer. So using what you learned just now, let's use that and apply that process to figure out the names of the following ionic compounds. In the first example, your formula is Na2O. We know that Na from the periodic table is sodium. Remember, I am not going to change the name of sodium in any way, shape, or form. Then I look at my anion, which in this case is oxygen, and oxygen will turn into oxide. Notice how I modified the name of oxygen so that I could write the word oxide and end with IDE. The second one is Ba3P2. I want you to notice something. These numbers that we have on the bottom, they have absolutely no role in determining the name of the binary ionic compound. They could be 35 and 28 for all we care. What we need to pay attention is the Ba and the P, okay? And so barium is Ba, and we know P is phosphorus, so we will change its name so that it ends with "ide", and phosphorus becomes phosphide. The third one is FeI3. We know Fe is iron, and I is iodine, so we'll change its name from iodine to iodide. Alright, so using these three examples, I hope that you have a pretty good understanding of how to name chemical formulas that are binary ionic in nature. Next up, let's learn how to write the names for ionic compounds that are tertiary in nature. As I had mentioned in the previous part of this video, a tertiary ionic compound is going to be a combination of some kind of a metal that is bonded with a polyatomic ion. Okay, this polyatomic ion is going to be in the back of your periodic table, so please make sure that when I say the word polyatomic ion, that is your cue that you should turn to the back side of your periodic table. Before we go any further, let's learn how to identify a polyatomic ion. Let's take an example of Na2CO3. You will notice that in this example, you have your metal, which is sodium, and that sodium metal makes a positive ion. But then you will notice that the leftover is CO3. In CO3, you have two different nonmetals, carbon and oxygen. That is how you know that this is a polyatomic ion. It's polyatomic because it has two different nonmetals that are bonded together. So polyatomic ion is a combination of two or more nonmetals. You will notice that frequently polyatomic ions mostly contain some amount of oxygen. And now that you have identified the metal and the polyatomic ion correctly, writing the name of the chemical is really simple. All you have to do is, just like in the previous cases, write down the name of the metal, which in this case is sodium, followed by the name of this polyatomic ion. You will find the name of this ion in the back of the periodic table, and it happens to be carbonate. And just like that, you have named the compound Na2CO3. That is all there is. You look at the formula. Once you have figured out that the formula you're looking at is that of an tertiary ionic compound, you write down the name of the metal, then you write down the name of the polyatomic ion. Both of these you will find in the periodic table, this from the front and this from the back. And that's all there is. So let's take a couple of examples and make sure that we understand this correctly. Here's the first example of a tertiary ionic compound. Just to review, we know this is tertiary because there is a metal, and then this is your polyatomic ion. We know this is polyatomic because it has two nonmetals. So the process is you write down the name of the metal, which you found from the front of the periodic table, and then you write down the name of the polyatomic ion by finding PO4 in the list of polyatomic ions. And when you do that, you will find out that PO4 is phosphate. And that's all. So Ba3PO4 is called barium phosphate. Just to make sure that you understand this correctly, I'm going to give you one more formula and see if you can write down the name of this formula on your own. Naming tertiary ionic compounds is simple once you know the correct name of the polyatomic ion. Not every polyatomic ion will be listed in the back of your periodic table, but there is a simple rule which will enable you to write the name of any polyatomic ion. When you look at the list of the polyatomic ions, you will notice how most ions end with the suffix ate, ate. We call such ions whose name ends with ate as base ions. Once you know the formula of the base ion, you can then use the following rule to name the ion in front of you. What I just said might not make any sense right away, so let us take an example and learn this rule. So you will notice that in front of you, I have written down 4 different formulas that at a glance look pretty similar to each other. The only difference that I hope you've noticed is the number of oxygen is different in each one of them. So this one has 3 oxygens, this one has 2 oxygens, this one has only 1, and this one has 4. If you were to find these polyatomic ions, the ones that I'm circling, in the back of the periodic table in that list of polyatomic ions, then you will definitely find this listed under the name chlorate. And the fact that it ends with 8 makes it a base ion. The reason why we call this a base ion is because now you will use the name of this base ion to kind of take it and modify it a little bit to indicate that every time the number of oxygen is changing. So for example, in this second example of NaClO2, if you compare the ClO part with that of the first one, you will notice that this one is one less oxygen. This one had ClO3, so it had 3 oxygens, and this one has 2 oxygens. So we need to make sure that we indicate that in our name. As a result, you will take the suffix ate away and replace it with ite. And so chlorate will turn into chloride. Now let's look at the third one. In the third one, you have 2 less oxygens compared to the base ions. And so in that case, to indicate that you have 2 less oxygens compared to your base ions, you're going to give this a prefix. You're going to give this a prefix hypo. And then retain the ite. What does that mean? It means that your base ion chlorate is going to turn into hypochlorite. In this last example, you will notice that I have 1 extra oxygen compared to the base ion. In the base ion, you have 3 oxygens, and on this example, I have 4 oxygens. So now, in contrast to the first 2 modifications of the base ion, this third modification is where you have 1 extra oxygen. So let us see how the name of this ion is going to be modified. Instead of changing the suffix of the anion, you're going to add a prefix per, okay, per. And so per is a prefix that denotes you have 1 extra oxygen compared to the base ion. And so per means 1 extra I apologize. Looks like I can't spell anymore. It's quite late at night, and this is getting hard. Anyways, so considering you have 1 extra oxygen compared to the base ion, you add the prefix per to the base ion's name, and ClO4 then becomes perchlorate. Okay, so these are the 3 ways that the name of the base ion can be modified to reflect the change in the number of oxygen atoms. So in this next, the last section of this video, I'm going to help you practice naming these polyatomic ions using a couple of examples. So to begin, let's look at this example of KNO4. KNO4 is made up of 2 parts. The potassium part, which is the metal. Naming that part is easy. You just look it up in the periodic table and you write down its name. But for the other part, which is your NO4, you will notice that this is not in the periodic table. But what is in the periodic table is NO3. And you will notice that NO3 is called nitrate. Now the fact that nitrate, which is your base ion, has 3 oxygen atoms, and the example in front of you has 4 oxygen atoms, the example has 1 extra oxygen compared to the base ion. And so like what I said just about 10 seconds ago, you're going to add the prefix per, PER, to the name of the base ion, and so NO4 becomes pernitrate. And so the complete name of KNO4 then becomes potassium pernitrate. Similarly, KNO2 is K, which is potassium, and then NO2 is one less oxygen compared to your base ion, which in this case is nitrate. And so because it is one less oxygen, you are going to get rid of this 8 suffix and replace it with ite, and so nitrate becomes nitrite. And that is all there is. So the key in figuring out the right name of the polyatomic ion is paying close attention to the formula of the base ion. Once you know the correct formula of the base ion, which is the one that ends with 8, then you can easily modify it to reflect the change in the number of oxygens. And so on the next page, I'm going to give you some examples of formulas with polyatomic ions in them, and I want you to write the proper names of those chemicals. Alright, so these are your 5 examples that I want you to work on. Please make sure that you understand that these are all tertiary ionic compounds, meaning that they are composed of a metal part and then a polyatomic ion. In some of these, the polyatomic ion is the base ion, and in some of these you're going to have to change the name of the base ion to indicate the change in the number of oxygen. Please make sure that you work on this on your own, and if you have any questions while you're watching this video, please write them down on the side in your notes and make sure that I get those answered in class. In this video, we went over the different rules for naming ionic compounds. We also went over some of the simple steps to name polyatomic ions, which are extremely important in getting the correct name of the tertiary ionic compound. I recommend that you watch this video a couple of times and make sure that you take detailed notes, and more importantly, write down any questions that you might have and get those answered in class from either me or from your teacher. And as always, thank you for watching and good luck.